This is the practice exam, X1. I'll go through the first three questions here. And the first question is asking about the gradient descent. And we have the cost function. And we have A. And the gradient descent formula is always W is equal to W minus the gradient with respect to W. And the cost function C is equal to this thing here. So basically the idea is to just differentiate this and figure out a number. Of course, there is the learning rate. We know it's 3 here. So now let's take the derivative. So whenever we want to take a derivative, we always use the chain rule. So C is a function of A. Y is given, Y is a label. So we take derivative with respect to A. And here we are doing stochastic gradient descent, so we only care about AI without the sum. So if we are doing batch gradient descent, we need the sum over I. But here we don't. And AI with respect to W. And each of them should be easy to differentiate. So if you look at the function C as a function of A, it's just minus yi divided by AI minus 1 minus yi divided by 1 minus AI. I think there's a minus sign here, so when you do like the chain rule inside the chain rule, you get another minus, so it cancels out with the minus in front. And this thing is the DC dA part, and then dA dW part is just this, A with respect to W, and here W is a single number, so there's no transpose, so the derivative is just xi. So I guess now we get the formula. We have most of these things, right? So we know what yi is. Yi is 0. And we know what AI is, do we? No. So we need to compute AI. AI is Wxi plus B. And I think we know what all of these things are. W is 4, Xi is, we know, is 5, B is minus 1 here. So we know AI, substitute these in here, and at the end we also know Xi is 5. So this Xi is also 5. So we know everything. We can substitute all of these, and also we know alpha is 3, and now we computed this thing, we can compute the W. And of course we know the original W is 4, 4 minus 3 times whatever this derivative is. And you can take the other derivative yourself. It's very simple. It's just, I think the end result is just replacing this xi by 1. What I mean by the other derivative is derivative with respect to B. So the B update formula is exactly the same, except for it's differentiating with respect to B. And the next question is kind of a concept question. So you have a function, and say it's something like this, and at x is minus 1, you have the situation where the derivative is larger than 0. So I think different randomization will have different sign here. So it may be larger than 0, less than 0, or equal to 0. But when it's larger than 0, it means it's this case here. So when the derivative is larger than 0, and you are doing gradient descent, not gradient ascent, so we're trying to find a minimum. So if you look at the diagram, it should be clear. We should move to the left, because the minimum is somewhere on the left. So right now we're at minus 1, so moving to the left means either minus 3 or minus 5. Of course, if you have equal to 0, then it should stay at minus 1. If you have less than 0, it should move in the other direction. You can also remember it this way: gradient descent is always moving towards the negative direction of the gradient. So if it's positive, move towards the negative direction. If it's negative, move to the positive direction. So the next question, we actually did this during the lecture. So all you need to do is assume we are doing a binary classification, and assume we have fxi is either 0 or 1. I think the question is actually not that clearly stated, but I should probably add this. But in any case, we just have 4 cases: the actual label and the predicted label. So there are 0, 0, 0, 1, 1, 0, and 1, 1. So in all 4 cases, you compute the cost, which should be, if they are the same, is 0. If they are different, then there's a mistake of 1. So you do the same thing with all the choices. So choice A is, you can check all of these. So putting these 2 numbers into this expression, and you don't actually need to sum them because you only care about one term. If one term is equal, then it should be equal for the other ones. So it would be the sum. But in any case, that would be 0, 1, 1, 0. So A is equivalent. And the question is asking for equivalence, right? Yes. So A is equivalent. And B is when they are not equal. Again, the notation is not great. There should be a 1 here, and it will be 0, 0, 1, 1, 0. When they are not equal, it's 1. When they are equal, it's 0. So B is correct. And that means D is the opposite. 1, 0, 0, 1. And then C. So you can actually try this. Putting all the numbers, so try 0 and 0, you get -1 times -1, and 1 minus 1, which is 0, max of 0 and 0 is actually 0. So it turns out that works. And when one of them is 0, the other one is 1, then the first part would be -1, and the second part would be 1. So this becomes 1 minus -1, which means 2. And actually, if I have the half, then it works. Now, this doesn't actually work. So it's 2 and 2 and 0. So I think during the lecture, we had the half. Here, I forgot the half, so that's not equivalent. And we can try the last one. So if both of them are 0, then it's max of 1, 0, and 1 minus 0, which is 1. So E, immediately, they're not the same. So E is not correct as well.